Video, I'm going to teach you how to make a full color red, green, blue, or RGB color picture out of 3 black and white images. Let's go back to our JS9 website here. Once again, js9.si.edu. Load up a fresh page. And we're going to load up 3 black and white PHYS images, each of which was taken with a different color filter. Now, I've got some that are already set up, and of course for the ones that you'll be working on, you'll have them set up this way as well. Let's go to File, Open Local, and in this case I'm going to load up 3 pictures of the Orion Nebula, 3 images of it, taken with first the red filter, that's M42 for the Orion Nebula, _R for red. Next, I'll load up one taken with a green filter, G. And finally, open local, one with a blue filter, labeled with B. Okay, let's do our basic setup here again. I want to make the display window larger, so I click and drag at the lower right and move that out. By the way, you can get rid of those help file things. It says you want a pristine JS9 display, and you can get one that's all like that. You know what? Let's actually go with that there. You don't need to have the help files up there. And if you did, you could just load up another window or tab with that in it and it would have it. So let's go back here. Red, green, and B for blue. All right, I'm going to size each of them to the display window, but let me make that display window fit my browser. There we go. Now I've got to do it separately for each one. The changes you make to one image are not made to the other images, with a couple of exceptions, and that's when we get in the combined red, green, and blue together. Now, as I've been saying, these are really black and white images. If you, you can color it any way you like, as long as you remember it's black and white. Now let's see here. This one, which one is this? That's the red image there. Okay, R. And take a look here. Under the color maps, gray is what we've been using. I often use, in my own research, something called a heat color map. Now, in each one of these, the bar that you're seeing displayed shows you what it's going to color the dim pixels with on the left. That'll be kind of black. What it'll color the bright pixels with on the right. That'll be white. And in between, in this case, it's got shades of orange. And that actually gives me a little more dynamic range than the regular grayscaling does. There's a cool one, which sometimes I like using. It does about the same. Turbo here. This one you used to see a whole lot in astronomy press release pictures because, well, in the early days when we were doing only black and white imagery and we didn't really combine them into red, green, blue color images, maybe this is because it was a way of at least letting the public see something more visually interesting. In this case, dark pixels are dark blue, bright pixels are dark red, and then we've got these brightnesses in between go through all the colors of the rainbow. Look what happens as I adjust brightness and contrast here. This is actually quite useful for seeing where there are subtle differences out there. But you've got to keep in mind, it's still a black and white photograph. You're just displaying it with color information telling you the brightness information. That is, the colors telling you the brightness information. But it's quite handy for some of that stuff. Viridis, it's kind of recently popular. I don't particularly like it. Magma, SLS. I forget why it's abbreviated that way there. Some program probably. And then we got red, green, and blue. Okay, and then more color maps. You've got all kinds of things like that there. Useful for certain things, but not for what you're going to be doing. Let's go back to gray. All right. So, here's the neat thing. Well, not the neat thing yet. Let's make some basic adjustments to our pictures. Let's set the minimum and maximum, make sure they're all logarithmic. Scale, logarithmic. Let's go to scale controls. And once again, about 545. Let's put 550 for the minimum. And let's put, what was it around here? Let's put 15,000 for the brightest. Okay. Now let's go to the next picture for green. I'm going to check. Now, the red, the green, and the blue images may not have the same upper and lower brightnesses because there's color out in space there. And so that means that there's going to be more of one color than more of one, well, red or green or blue primary color than there are of the others. Okay, but I'm getting similar numbers there. 550 and around here 1700. Actually, let's go 17,000. Let's go 17,000. And I'm going to do the same thing for the red. 17,000. Notice I've already made some adjustments to the brightness and contrast there, and I probably shouldn't have. Okay, and here it's definitely fainter there than the other two filters. We'll do it the same way. Okay, 550, 17,000. Okay. Now, what we can do is, by the way, under color, you could always just go to, under scale, data limits low and high, and simply enter them here without having to go to the scale controls. But it's handy to have that scale control window up. All right, now what we're going to do. This, what I've got with a B, was taken with a blue filter. So let's go into color, and we're going to color it blue once we're happy with the way it's set up. And there it's blue. The darkest pixels are black, the brightest ones are a deep blue. Let's go to the green filter. We'll do the same thing, but color it green. And let's go to the red filter picture, and the same thing, but color it red. Now, here's the neat trick. If we go to color, go all the way down to RGB mode, what this will do is it'll take, if you've assigned one picture is red, one is green, and one is blue, when you create RGB mode, it combines them to make full color. There's your color picture. Now, that looks very rose-colored, doesn't it? In fact, much more so than the real nebula is. The reason is I had been adjusting the brightness and contrast of the red picture, and I didn't do it to the others. Watch what happens as you see here the red color bar is showing down there. I don't need that. The red color bar is showing down there, which tells me I'm working on the red picture. I can only work on one of those three at a time. Not on all three together. And if I decrease my contrast and brightness like that, I'm doing this kind of by eye to make it come out and look right. That kind of gets me a fairly natural looking picture to it. But we don't want to rely on having happened to have just adjusted it by eye until it looks good. We want to have the brightness and contrast be the same for the red, the green, and the blue images. So how do we do that? Aha! Go to scale. And, let me see here, go to color. And you see where we've got contrast and bias here. Pardon me just a second. Let's set that to do not disturb here. Contrast and bias. We can enter, that tells me what the contrast level is and what the bias level is currently. And I'm going to reset that there. Aha, that's kind of what the others were set at. But I can adjust those. So let's go to color controls. We'll have that floating out here. Now, let's say I want to have a little more contrast like that, all right? So contrast is 2.6. Contrast goes from high contrast is 10, low contrast, oops, sorry, that's bias. Okay. When I bias it very bright, it goes to 0. When I bias it very dim, it goes to 1. Contrast goes from a maximum of 10 down to a minimum of 0, like that. Okay, let me reset this again. All right, now we can see kind of the natural color there. All right, so what I want to do is, let's say that I want to make a higher contrast image. I want to emphasize certain features of this nebula. Maybe the best thing to do is I'm going to remove the red image, put it back into black and white mode. It's easier to see that way. So I'm just going to do color. Oh, by the way, look here. Now, when you see the images, when you've got them assigned to red, green, and blue, the file names have red or green or blue in parentheses next to them, so you can keep track of which one is assigned to which color. Very handy. So, if I say, now see here, I'm working on the red image. If I just say go back to gray, it goes to just, I'm only displaying the red image in grayscale, and I don't see the others now. They're invisible. If I go back to my files, see that it's removed the red in parentheses there. All right, let's see maybe a part of the nebula I want to emphasize here. About like that. Okay, I'm going to overexpose the center, but I'm going to then bring out the dust and gas in the outer parts here, and especially that area right there. So that's got a contrast of 1.8878, and I'm going to highlight and copy that. And then 0.3542 for the bias. Now watch this. If I go over to the green, I just paste that on. I'll do the bias next, and the blue, paste that on and enter. Go back to my red, and it made a whole lot of extra decimal places past that just because of the way it rounds things off, or in this case doesn't. Don't worry about that there. After the first couple of decimal places, it doesn't make much difference that you can see. So I've copied the bias now, 0.354 something. Okay, I'm going to go back to my red, and I put it back in the red, green, blue stack by assigning it red. There. And now all of them have the same contrast and brightness, so that I get a much more natural looking color on this. And in this case, notice that the center part, the brightest part of the nebula, is indeed overexposed and just bright white. That's okay, because I was adjusting it to see the dimmer outer parts and to bring out the contrast in the colors there, which we can see now. Now, once you have it in a way that is useful and you want to look at it, we might do things like we might want to zoom in on the relevant part of it, and notice that when you've got them stacked with red, green, and blue together, when your zoom controls work for all of them together that are in that stack. If I click and drag to move the image, all of them move together. Zooming in, same thing, they all go together. All right, so let's say that this is what I'm interested in now. I have not physically changed either any of those three files. The PHYS images are unchanged by any of this stuff that I do. But I've got a displayed image that's different. So what I want to do is I want to save that displayed image. And we go to File, Save, and under Save Displayed Data As, choose either JPEG or a PNG. PNG gives you it's better, but it takes up more memory. JPEG does a little bit of compression. Let's save it as a PNG. And off it pops. On a Macintosh, it'll save it to your downloads folder. On a Windows computer, it saves it to somewhere else. Now, notice the file name it gave it. It's whichever of those three images I had popped up here was the displayed part, at least for those purposes, and it just gives it that file name with a .png at the end. You'll want to retitle that because this is not just the red layer, this is the full color. You want to retitle that then and save it in your working folder. All right. And there you have it. That's your color image.